addition and subtraction of polynomials. So I'm adding. This is not FOIL. This is not the box method. This is addition and subtraction. And so I'm going to what is usually described as distribute the addition or distribute the subtraction over the parentheses. Okay? I don't describe it that way very often, but it can be described that way. In other words, I'm adding all of these things to all of these things, and so I'm going to look for like terms. I've got the x squared like terms, I've got the x like terms, and I've got the constant like terms. And so those things will be matched up in order as long as the polynomial is written in standard form. In other words, with descending exponents, x squared, x, and then constant. So let's not make it more complicated than it needs to be, right? I've got 2x squared minus 6x plus 5 plus 8x squared, right? Plus minus 21. You can say plus negative 21 plus minus 21. I'm adding this term, which is minus 21x, and I'm adding this term, plus 4. Okay, and so now I do my like terms. I've got x squared terms. So 2x squared and 8x squared is 10x squared. I've got minus 6 and minus 21. Minus 6 and minus 21. So if I start at negative 6 and I subtract 21 more, that's negative 27x. If you get stuck with those, think about it on the number line. Right? I'm starting at negative 6 and I'm going 21 more negatively, 21 more to the left on the number line. Okay? And then I'm going to add my constant terms. 5 and 4 plus 9. So my constants added to 9, right? My x terms added to negative 27, and my x squared terms added to 10. Okay? So I tried to match those up by color. Hopefully that's helpful and not too many lines. Let's look at one slightly different. How about x plus 3? How about x squared plus 3x plus 5x? No. Make it minus. Minus 5x squared minus 6x plus 2. Okay? So my like terms are my squared terms. I'm subtracting. So x minus 5x squared minus 5x squared is negative 4x squared. So you can do your work on the side if it's confusing or if you're struggling. So I have negative 4x squared. My next term is 3x. I've got a 3x here and a minus 6x, but I'm subtracting. If I subtract negative 6x from 3x, so I have 3x, and I'm subtracting negative 6x. If I subtract a negative, that becomes positive. So 3x plus 6x is plus 9x. And then I don't have a constant in the first part, so I'm subtracting 2. And so when I'm done, I have negative 4x squared plus 9x minus 2. So that's adding and subtracting polynomials. Part 2, multiplying a polynomial by a monomial, right? So I'm just multiplying by a term, not the sum or difference of 2 terms or 3 terms, which is what we did on Thursday, which is today. Okay? And so I've got 3c times 2c cubed plus 5c minus 7c to the 6th. Notice that polynomial, the second polynomial, is not in descending order. Okay, it doesn't have to be mathematically, but when I'm finished, I should write the polynomial in standard form because I'm simplifying, and so when I'm done simplifying, I want it to be in standard form. So I'm going to distribute the 3c over the parentheses, and that's mathematically the way that would be expressed. So it's going to be 3c times 2c cubed. So 3c times 2c cubed, I've got the 3 times the 2 is 6. I'll write it in the answer space. And I've got c times c cubed, so that's c to the first, c cubed, so that's c1 plus 3, c to the fourth. This is a positive 3, so the signs will stay the same. So I've got a plus, and now I've got 3c times 5c. 3 times 5 is 15. C times c is c squared. I've got the minus. I'm subtracting. 3c times 7c to the sixth. 3 times 7 is 21. C times c to the sixth, that's c to the 1 plus 6. Multiplying numbers of the same base, c to the seventh. Now I just said I should write it in descending order, so that's going to be rewritten. I'll do it down here at the bottom in yellow. Negative 21 c to the seventh plus 6 c to the fourth plus 15c squared. So that would be a better way to write it in the answer space. So I'll just go ahead and move that up. Negative 21 c to the seventh plus c to the fourth, 6 c to the fourth plus 15 c squared. Okay? Okay. And finally, what we spent some time on Thursday was multiplying binomials and polynomials, right? So it's a binomial. This is multiplying two binomials because they each have 1, 2, 1, 2 terms. It's polynomials, so you might have 3 terms. It could be a quadratic expression times a linear expression. This is 2 linear expressions. I could multiply any 2 polynomials. There is no real rule about what I can and can't do. I can do them all. Okay? It's just a matter of complexity. So we've got FOIL and we've got box methods. So let's look at FOIL first. I've got, let's use green. I've got 3x minus 2, x plus 5, and I'm going to FOIL. So FOIL means firsts, so that's 3x squared. Outers, 3x times 5 is plus 15x. Inners is minus 2 times x, which is minus 2x. And lasts, it's minus 2 times 5 is minus 10. And so my answer is 3x squared plus 15 minus 2 is plus 13x, and then minus 10. If I do the box method, I should get the same result. I know some of you like this, I know some of you don't. 3x, negative 2, x, 5. You can always use whatever method works. So I'm finding the thing that goes in each little square is the product of its 2 sides. Okay, and so the top left square has x right here, and it has 3x, and so that's going to be 3x times x, or 3x squared. X times x is x squared. Moving to the right, I've got x times negative 2. It's negative 2x. Lower left, I've got 5 and 3x. That's 15x. And lower right, I've got 5 and minus 2. That's minus 10. And then if you have these two numbers written in the same order as these two and they're the same degree, so I have an x and a constant, or it could be an x squared and an x, as long as they're the same across as they are down, I will end up with like terms here, called that the peanut, right? And so I've got from this purple, I've got 3x squared. For my x squared term, I've got 15x down here, and minus 2x, that's plus 13x, and then I've got my minus 10. Okay, and I should get the same answer. Okay, I'll do one where it's a 3 and a 2. So let's say it's 2x squared plus 4x minus 6 times 5x minus 2. Okay, I'm just doing the box method here. I could do FOIL-ish, okay, but it's not FOIL because, you know, there's more than two binomials. I mean, there's more than two terms in the two polynomials that are being multiplied. So now I have to write the trinomial going down. So I'm just going to write 2x squared. I'm going to write 4x. I'm going to write minus 6. And across, I'm going to go 5x. And I'm going to go minus 2. Okay? And so, same idea. Now I've got 5x times 2x squared. That's 2 times 5 is 10. X squared times x is x cubed. I've got 2x squared times negative 2, so that's going to be a negative 4. And x squared, and it's a constant, so it's x squared, right? Now I'm going to go to the second row. 4x times 5x is 20x. 4x times minus 2 is minus 8x. Last row, minus 6 times 5x is minus 30x. Minus 6 times minus 2 is 12. Okay, and so, whoops, left one thing out. That should be squared. Hope you caught that. The 4x times the 5x should be 20x squared. So, now I'm looking at like terms. The bottom right is by itself. That's just a 12. I'll write it up here. Then I have like terms. Minus 30 minus 8 is minus 38x. Then I've got my squared terms. Aligned diagonally, 20x squared minus 4x squared is 16x squared. It's plus 20 minus 4, so it's 16x squared, and it's plus. And then I've got my cubed term, which is 10x cubed. Okay, so 10x cubed plus 16x squared minus 38x plus 12. This grid could multiply as many, you know, as you want. Could be 3 by 4. I could have a trinomial times a quadnomial, and I would get like terms, like terms, like terms, like terms. It would just work that way. Okay? So you can use that method, and I think it works pretty well. I know I'm a visual person. I know lots of you are too. And so for me, that method works pretty well. I also have a lot of practice, and so I can do it the other way as well. But this really keeps things organized. I really like the box method. I know a lot of you do also, and I think for the same reason.